Hi viewers, this is Dr. R. Padmapriya from St.Joseph College of Arts and Science, Cuddalore, working as an assistant professor in PG and Research Department of Mathematics. We are going to discuss about the topic gamma function in calculus. First, let us see the definition for gamma function. If n is positive, then the definite integral 0 to infinity e power minus x power n minus 1 dx when n is greater than 0, which is a function of n, is called the gamma function or Euclidean integral of second kind and is denoted by gamma n. Thus, gamma n is defined by integral 0 to infinity e power minus x power n minus 1 into dx, n is greater than 0. When we substitute n is equal to 1 in the integral, then gamma 1 is equal to 0 to infinity e power minus x power, in the place of n substitute 1. Therefore, 1 minus 1 is 0, x power 0 is 1. So, we get the integral like this, 0 to infinity e power minus x into dx. Now, integrate e power minus x into dx, we will be getting e power minus x by minus 1. Integral 0 to infinity. When we apply the upper limit e power minus infinity, the value is 0, and the lower limit minus of minus plus e power 0 is 1. So, the answer is 1. So, gamma 1 value is 1. Now, let us see the reduction formula for gamma n. Let us see gamma n plus 1. In the formula, apply in the place of n, you substitute n plus 1. So, integral 0 to infinity e power minus x power n plus 1 minus 1. So, plus 1 minus 1 get cancelled. We will be getting x power n into dx. Here, we are going to use the udv formula. Now, consider this value, that is x power n into dx as u and e power minus x as dv. So, differentiate u with respect to x. We will be getting n into x power n minus 1. When we integrate e power minus x, we will be getting e power minus x divided by minus 1. So, the formula for integral u dv is uv minus integral v du. So, substitute the values. U value is x power n, v value is e power minus x divided by minus 1, integral 0 to infinity minus integral 0 to infinity uv minus integral v du. Here v value is e power minus x into du. Du is n into x power n minus 1 into dx. So, in the first value, when we apply the limits, e power infinity is 0. So, the upper limit will be 0 minus, when we are substituting the lower limit 0, e power 0 into 0 power n. So, the value is 0. So, the first value becomes 0. The second value is n into integral 0 to infinity e power minus x power n minus 1 into dx. This is nothing but the formula of gamma n. So, instead of this integral, you substitute gamma n. Thus, gamma n plus 1 is equal to n into gamma n. That is the before value. You have to write the before value, n gamma n. If n is a positive integer, then by repeated application of the above formula, we get gamma n plus 1 is equal to n gamma n. So, in the place of gamma n means that before value. that is n minus 1, gamma n minus 1. Again, in the place of gamma n minus 1, what is the before value? N minus 2, gamma n minus 2. So, likewise, we substitute all the values. Finally, we will be getting gamma 1, that is, gamma 1 value is 1. So, the sequence is like this, n minus 1, n minus 2, n minus 3, etc. up to 1. So, this value is nothing but the n factorial. So, the value of gamma n plus 1 is n factorial. We can also tell gamma n plus 1 is equal to n gamma n or n factorial. Now, let us derive the value for gamma 1 by 2. We know the value for gamma n, that is the formula for gamma n is integral 0 to infinity e power minus x power n minus 1 into dx when n is greater than 0. In the place of n, substitute 1 by 2, that is integral 0 to infinity e power minus t. In the place of x, you substitute t, e power minus t into t power. In the place of n, when we substitute 1 by 2 minus 2 is minus 1 by 2. So, t power minus 1 by 2 into dt. Now, putting t is equal to x squared, so that when we differentiate, dt is equal to 2 times of x into dx. So, in the place of t, you substitute x square, that is integral 0 to infinity e power minus, in the place of t substitute x square, in the place of t you substitute x square, that is x square, in the power we are having minus 1 by 2. So that 2 into 1 by 2 get cancelled. We will be getting x power minus 1. X power minus 1 is nothing but 1 by x. So we written as 1 by x. What is the dt value? dt value is 2x into dx. So substitute in the place of dt 2x into dx. X value get cancelled. So the remaining value is put that 2 outside the integral. So 2 times of 0 to infinity e power minus x square into dx. You consider this as first equation. Writing y for x, we have in the place of x just substitute the value of y, that is 2 times of 0 to integral e power minus y square into dy, and consider this as the second equation. If f of x and g of x are functions of x and y only, and the limits of integrations are constants, then double integration can be represented as the product of two integrals. Thus, integral c to d, integral a to b, f of x, g of y, dx, dy is equal to, we can separate this two integral like this, integral a to b, f of x, dx, and integral c to d, g of y, dy. From 1 and 2, we have, when we multiply the first equation and the second equation, in the left hand side we are having gamma 1 by 2 in the both the equation. So, we will be getting gamma 1 by 2 whole square. Come to the right side of these two equations, first and second equation. So, 2 times of, in both equation we are having 2 times of. So, that is when we multiply 4 times, we will be getting 0 to infinity e power minus x square dx, and for the y value 0 to infinity e power minus y square into dy. When we combine these two equations, two integrals, 4 times of integral 0 to infinity, integral 0 to infinity, e power, the base is same. So, add the power values. E power, take the minus as common, minus of x square plus y square into dx dy. Minus x square plus y square. Now, we are going to convert into the polar coordinates. Changing this into the polar coordinates, we will be considering x is equal to r cos theta and y is equal to r sin theta, dx dy is equal to r dr d theta. So therefore r varies from 0 to infinity and theta varies from 0 to pi by 2. So now we substitute. Left hand side it will remains the same. And you come to the right hand side, 4 times of the limit for theta value is 0 to pi by 2. The inner limit is r limits 0 to infinity e power minus x square plus y square, that is r square cos square theta plus r square sin square theta. Taking r square as common, we will be getting sin square plus cos square value is 1. So we will be getting e power minus r square. In the place of dx dy, you substitute r dr d theta. So you will be substituting. After considering this value r square as t, will be getting 2r into dr is equal to dt. So that's why in the place of e power minus r square, you substitute e power minus t into r dr. In the place of r dr, will be getting dt divided by 2. So when we integrate e power minus t, we will be getting e power minus t divided by minus 1. So that's why already we are having dt by 2. So we will be getting this integral minus 1 by 2 e power minus r square 0 to infinity into d theta. And we cancel that 4 divided by 2, that is 2 times of 0 to pi by 2 into d theta. After applying the limits, when we apply the upper limit, e power infinity is 0 and lower limit means already we are having one minus, so for lower limit we are having minus, so it will become plus e power 0 value is 1. So we will be getting d theta. So 2 times of integral 0 to pi by 2 into d theta. So when we integrate d theta, we will be getting theta upper limit minus lower limit means pi by 2 minus 0. In that pi by 2, 2 and 2 get cancelled. So the answer will be pi. So in the left hand side, we are having gamma 1 by 2 square is equal to pi. Taking square root on both sides, we will be getting this value gamma 1 by 2 is equal to root pi.